All right, hello everyone. So today I am going to continue going over the project that we have successfully finished and trying to understand all of those points that we might have been glossing over during the actual building process. So obviously when we're building the project, we're just trying to go as fast as possible. We're trying to build things, and once it works, you kind of move on. That's very natural. Just like, okay, great, it worked. Awesome. Let's move on to the next thing. But I do want to take some time to reflect back, take a breath, and say, okay, let's go and actually learn the concepts and understand what's happening. Because that's the entire point of building the project is to be able to learn and to understand better and have a better idea of what software engineering is and become a better software engineer. So, if we don't take some time to actually digest what we actually learned, well, then we've kind of cheated ourselves. So, this is, let's make myself a little bit smaller. And what I want to do right now is look at this right here. So, try to understand how does volumes work within Docker? What is this PG data? Okay, and then also understand, well, I know that this stands for Postgres, right? And its data. It is the database in which my Postgres is going to store the data in the database, and I know that it is persistent. How does my front end, which communicates with Postgres, how does that connection actually occur? All of those questions. That's what I'm trying to figure out right now. So I'm going to just copy and paste this into here and say, I now want to focus my attention on understanding the volumes and PG data portion of this. What exactly is PG data, and how does this connect to volumes in Docker? How do my individual containers interact with this PG data thing? Talk about any other related topics you think would be helpful to my understanding. Okay. Let's let it do its thing and find out what's going on. Okay, so Docker volumes, let's break down PG data, how it works, and why it matters, especially in your setup with Postgres. All right, what is PG data? In my Docker Compose, which is this one, this line, volumes, PG data, again, I didn't have this path right there. You're mounting. Okay, so from the video that we did about an hour ago, we learned what mounting was. Now let me try to recall what it was. We have an environment and we want to mount, which means kind of like expose files or folders. Okay. So this is kind of like a test for myself because the video immediately previous this current video, I was going and investigating some of the other concepts within this Docker files. So in specific, I was doing a lot of the networks and trying to understand how the build process works and what an image is, what a container is, how those two are connected, what the IP address of each container is going to be, how they're able to communicate on their local area, or local area network. I mean, just their local network. And then how they're exposed to the outside world, etc. In that video, we came across this idea of mounting. And so it's kind of like a quiz to me. Okay, 3 hours or 1 hour, I can't remember. I think it's actually about 3 hours ago. We learned about mounting. What is it? So you have an environment, either a virtual environment or in this case, a container, okay? And you want to expose a file system or a file or a directory, and you want this environment to have access to it. So you have to mount this external file to the environment, and therefore your environment is able to read and write to that file. And in specific, what it was talking about in the last video, that was I was trying to build something. I was trying to understand, okay, well, if I change my app.js, which is on my front end, where is front end? Here's front end. If I change my app.js, and that should, in here, look, it's running app.js. So it should see, or it should be running a different file, right? That was my conception. And the answer is no, because the image, when I do Docker build, right? Or Docker compose up build, when I do that, it goes through and it runs this command, or it runs this Docker file, and it does capture all of the files, okay, which include this app.js, and it saves that in an image, and this image is self-containing. Notice the image does not connect to now my actual app.js. It has its own app.js. And what was being said is you can mount, if you do want your actual app.js, which is on your local Mac device, to be reflected in the Docker image, you can mount this location into your Docker image, and that allows Docker to be able to read and write from app.js. So that's what mounting means. Okay, I think I passed the test. I hope I did. Okay, anyways, now we come into this mount again. So there's another mounting idea. You're mounting a Docker image, or Docker manage volume. Okay, what is that supposed to mean? So I am mounting a Docker. So I think my container is going to be exposed to a Docker manage volume, which is pgdata. So pgdata is like the file system, or the file that I am trying to allow my container to talk to. I think that's what this sentence means. Inside the container, this volume is attached to the path here, var lib postgres data, okay, which is where Postgres stores its database files, okay? So PG is a persistent storage location managed by Docker that lives outside of the container's life cycle. Okay, so this is... So it means that this PG data is somewhere in my Mac's file system, stored on my local device, and I am allowing access to it. Good thing I learned about mounting in the last video. Now I can kind of understand what's going on in this one. Okay, why use volumes? Without a volume, the container is deleted. All data is lost. You'd lose your database every time you rebuilt or restarted the container. Okay. With a volume, the data in PG data persists even if the container is removed. You can recreate the container and still access the same database. How containers interact with PG data. Okay, I feel like there's a question here. I didn't specify any path in my Docker Compose file, but it seems to be working anyways. Okay. So, oops, I'll use vol. Okay. How containers interact with PG data. Only the Postgres container mounts PG data. Postgres, okay. Image, restart, environment. But that's not the same thing as PG data. Volumes, okay. Oh, PG data, oh, there we go. Okay. And yeah, this is the only one that has that thing. That's the only one that has that volume. But okay, so now in my Docker Compose file, I have the, what do I call it? Postgres service, but this is not an actual microservice that I created myself. That means I don't have a folder on my local machine project which contains a Docker file. So I am trying to understand what this is, what is actually being built, and how it works. Is it a regular container just like my other Docker file microservices? Okay, we'll do that and then let it do its thinking for it and start reading here. Okay, so how they interact. Only the Postgres container mounts PG data. So that's true, we just saw that, okay? I didn't actually realize that until it said it just now. It reads and writes database files to this location. Okay, yeah, that makes sense. The volume is isolated from other containers. Isolated from other containers unless they explicitly mount to it. Okay? Your other services, like front end, interact with Postgres via networking. Okay, so I need to interact with this service or this container, I think. So there's going to be a container, and from our last video, now we understand networking a little bit better. And all of these all of these containers are on they have their own IP address, but they're on this local network, which is called Micronet, right? And that's created by Docker Compose, and it manages that. So I, from one container, am able to use the name of the service, in this case it would be Postgres, as the IP address, and I know the port that it's on, okay? And therefore I can talk to this container. Okay. Your other services like frontend interact with Postgres via networking, not by accessing the volume directly. Okay, so I'm not talking to the volume directly. Environment, DB host, Postgres DB port, okay? Yeah. 5432. 5432, yeah. Okay. Where is PG data stored? We already know that's on our local device. Okay. So, what I'm curious about right now is if I send data to this Postgres container, I know its IP address and port number, but how does that container actually know to take in the data, process it in a very particular way, know what format the incoming data is in, and how it should process those data or requests. Okay, so we are getting way off. Okay, I need to come back up here and say things that I should know about. Named volumes, like PG data, created and managed by Docker. Anonymous, created without a name, harder to manage. Bind mounts, so that's what we were talking about last time, is bind mounts and build mounts. Mounts a specific host path meaning my local device, to the container. Okay. Volume lifecycle. Volumes persist until manually deleted. So I can delete the volume, right? Multiple containers can mount the same volume for shared data or shared logs and caching. So I can communicate, or I can I could technically have these containers, microservices, talk to the same shared location. So how to backup or migrate, I can do docker run, is that remove? PG data volume, Okay. So you're at, okay, whatever. In your Docker Compose, you have this, right? Yeah. You didn't specify a path, PG data, and that's totally fine. Docker manages the volumes internally. You don't need to create a folder. Okay. I think it kind of answered it, because I was just looking here and I was seeing that I didn't create a path, but now I see that the path is up there. It's fine. What happens with the Postgres service? So, you're right, unlike your other services, Postgres isn't something you built yourself. That's correct, right? Like, instead, you're using a pre-built image from Docker Hub, okay? Which is Postgres 15, right up here, okay? This means Docker pulls the official Postgres image from Docker Hub. No Docker file is needed because the image already contains everything Postgres needs to run. It's still a regular container, just like your custom ones. The difference is that my microservices are built from source using the Docker file, which is in the particular folder that I give it. Okay, the Postgres service skips the build step and just runs the image directly. Okay, that makes sense. So build uses a Docker file. Postgres is the image. The source code is what I wrote. Control everything. Okay, yeah. Maintained by the SQL team. Environment variables. Okay, so I have to use those environment variables, which is here. Pulled from Docker Hub. All right. So now I'm asking about how it knows what, if I send it to a particular port, how does it know how to actually process that request? All right. How Postgres container understands the process data. When you send data to the Postgres container via its IP and port, typically, okay, yeah, here's what happens under the hood. Postgres is already running inside of the container, okay? So it has that software running, including a fully configured server. Okay, so it has its own API, like REST APIs, endpoints that are running on the exposed port. Okay. When the container starts, it launches Postgres, which listens for incoming connections on 5432. Okay? So I'm going to say, what if I want to run multiple Postgres containers in specific? How does this work with port conflicts? Okay. I'm gonna go like that. And we are on it speaks post. Okay. So it speaks Postgres protocol. Postgres uses binary protocol over TCP/IP. Okay. Clients, like my front end or database GUI, connect using the protocol, which defines how query parameters and results are structured. The format of incoming data is expected to follow this protocol. Okay, so the container doesn't need to guess. Okay, clients use drivers or ORMs. Oh, what's an ORM? Your application likely uses Postgres driver. Okay. Example PG from Node.js. Okay, so now let's actually get into my front end, because I think that's correct. So services, Postgres here. Okay, require PG. So we have this file, and we're grabbing it. Okay, it's pool, and then we are instantiating it. Okay, and passing in this JavaScript object. Okay, with all of the. So we're saying that the host is go look at this container's environment variables and get that host variable, which is going to be here. If we're in front end, we say, okay, this container, this environment, and this host is going to evaluate to Postgres. So we store that into there, the database host, okay? And then we store all of those variables. Okay. So your application likely uses this driver or an ORM. It's fine, whatever. These tools translate my app's logic into SQL queries and send them to the correct format. Oh, okay, so when I did those calls, which is in routes, index.js, and then, okay, so yeah, I'm operating off of this pool. So I'm doing pool, and there's a method within there, which is query, and then I give it some SQL language, okay, and then I pass in those variables. And then that object, or that method, will take in those or that item which I gave it, and then it will perform the appropriate communications with the where did it go? Come on, here. It knows the name that it needs to send it to, the port number it needs to send to, it has the password, etc. So it does the correct request over to my other container, which is running Postgres. And then it can send that correct message over to Postgres. Postgres now knows how to deal with it. It talks to the database, and then sends back the response. Okay. So once the server receives a query, it parses the SQL statement, validates the syntax, plans the query using internal optimizers, executes it against the data, okay? Why it works seamlessly in a container. The magic of containers is that they encapsulate everything Postgres needs. The database engine, configuration files, networking setup, data storage path, logging. Yeah, I mean, I'm starting to see that this is actually pretty cool because I'm able to just come in here and go create this image from this base image, right? And then I'm able to just have Postgres running. And then I give it my password and all of that. I tell it where I want it to store the data. I expose the ports and give it a network. And then from that, I am then able to go in and tell it okay, well, here is my username, database user, right, is here. I just give this library or this object all of the connection details it needs, and then it deals with sending all of that data or crafting the message to send to that IP and port number, and I tell it my name and everything, and then it sends it to that container. Then that container knows where on my local device the data is to be stored, and it deals with all of that that stuff. That's actually pretty cool. Okay. Bonus, authentication and security. Your container also knows how to authenticate incoming requests because you've set up variables like the password and everything. Okay, so what if I want to run multiple Postgres containers? In specific, how does this work with port conflicting? But you're right about thinking about port conflicts because Postgres defaults, yeah, that's why I'm asking about this, to 5432, and only one container can bind to that port on the host at the same time. Let's break down. Okay, so you're telling Docker map container port 5432 to host port 5432. If you try running a second container with the same mapping, Docker will throw an exception. Yep. How to avoid port conflicts. You simply need to map each container to a different host port, like this. So both of the ports on the container are 5432. Okay, so that was another misconception that I had was, okay, Postgres, that software does say I am only listening on this very particular port. That's what I was kind of curious about. Now I'm seeing, okay, yes, that's true. It's living in its own world and it says I'm only listening to this one port. Now, what I can do from Docker is I can just map any port that I want on my host OS to that 5432. So in this case, I'm mapping 5433 to 5432. So this is on my Mac. This is my local host 5433. And that gets mapped to this Postgres DB1 5432. And likewise, this one here, this is a different port on my local device, on my local Mac, that gets mapped to the same container, the same port here at this different IP address, right? Yeah. Okay. Or at this different container. Okay. Bonus tip for multi-container. Each container should have its own volume to avoid data overlap. Okay, well, I was just mainly curious about like how Docker containers and especially pre-built Docker containers can accept data, because on my end, I know that let me go to app.js here. I'm just specifying like port 3000. So I am the one saying, hey, I'm going to be at 3000. And then I spin up that Docker container. And that Docker container, I am only looking at port 3000. I'm not looking at port 3001, which is why I was thinking like, well, wait, hold on. If I just change the port, but I send it to this Postgres container, is it going to take in that, or does it still have to be very specifically 5432? From all of the servers that I built, both in JavaScript and in Java, I was the one who told the server where to be looking. So yeah, actually now that makes sense. Things are in order. Okay, well, I think we actually did go about accomplishing our goal. Like, that's what I was trying to figure out, and I think I figured it out. So I don't have a little timer that tells me how long I've been doing this video, but this one feels like it was kind of short. Normally the videos are a lot longer and it takes me a little bit longer to actually figure out what's going on, but I feel like I've accomplished it. So I'm going to leave the video off right here, and thank you guys for watching this video. If you want to continue on the journey with me of becoming a software engineer, learning all of those skills, improving ourselves, subscribe. I would love to have you along on the journey. And I hope everyone has a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you guys very soon.